In this video, we're going to discuss about stability analysis using RH criteria. The contents of this video is concept of stability, necessary condition for stability, Routh stability criterion. Let us begin with the concept of stability. Here I consider the system having input step signal and system is under damped. So this is the output response what we're getting. So what mean by stability then? The stability says that usually whether the system is reached steady state after passing through the transients or not. Usually the stability means in very simple words, if there is any small change in the input or initial conditions or some parameters, there should not be a large deviations in the output parameters. To say about the stability of the system, it has to follow two conditions. The first condition is the system has to produce bounded output for the bounded input, and second one is if input is 0, the output has to move towards 0 irrespective of initial condition. Consider transfer function and let them place these roots on S-plane which is having imaginary axis and real axis. The roots may be real number or complex conjugates. If these roots are left hand side of this S-plane, if right hand side of this S-plane, what happens? Let us see then. If all roots are left hand side, then system is called stable. If poles are right hand side, then system is called unstable. If roots are on imaginary axis, then this is called marginally stable. So the location of the poles is very important to say about the stability of the system. Well, let us consider necessary condition for stability. Here I consider one polynomial. The first condition is what it says that the coefficient of the characteristic equation should have the same sign. So look at that, all are having positive sign or it may be negative sign. Then second condition is the power must be in descending order or there should not be no missing terms. That means the order is 3, 2, 1, 0. If any one term is missing, that is not a necessary condition for the stability. But these conditions are necessary but not sufficient conditions to say about the stability of the systems. Sometimes the given polynomial may be stable or unstable by even though it's having these two conditions, we cannot predict it by using these two conditions. So therefore, we required mathematical calculations to say about the given system is stable or unstable with the help of Routh Hurwitz criterion or RH criterion. Well, let us solve one simple problem on stability of the systems for a given polynomial. Here is the polynomial the given. To solve this one, first what we need to do, you have to write all s in descending orders, s3, s square, s and s raised to 0. Okay. The next what we need to do, so you have to write the coefficient of s3 first. The coefficient of s3 is 1. Then you have to leave second term and you have to write third term. The coefficient of this one is 10. Again you have to leave this one, the next coefficient is not there, leave it. Then for the second row, what we can do, we have to consider the coefficient of s square, that is 5. Then again we have to leave this term, I'll write in different way, leave this term. I have to consider the next term, that is 3. Okay, After getting two rows, now how to do the calculation. The first calculation is starts with 5 into 10, 5 into 10. Next one is 1 into 3 minus 1 into 3 divided by this 5. So answer of this one is 9.4. So let us write the answer, that is 9.4 here. Now the next, these two terms are not available here, so obviously if not terms are not available, then you can put it 0. Then let us calculate that. Then next row calculation, that is for s raised to 0, 9.4 into 3. First term is 9.4 into 3. Second term is 5 into 0 is 0 divided by 9.4. This 9.4 get cancelled. The remaining thing is 3 here. Look at the first column here. The all signs are plus 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 only. The plus is not there. So default we know that plus 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 plus. That means the first column having the same sign, there is no sign changes, hence the given system is, or you can say that, stable system. Let us consider, okay, now we'll calculate stability of the given polynomial which is having order 4. So first step is we have to write s in descending order, s square s raised to 1 to 0. Okay, in the first row I have to write the coefficient of s raised to 4. The coefficient of s raised to 4 is 1. You have to leave this term to consider the next term, that is 4. You have to leave this term to consider next term, that is 8. For the second row I have to consider coefficient of s cube, that is 2. So whatever the terms you left out now, that I have to consider, that is 2, 6, and the last term is not available here. Let us put it blank r, even though you can write it 0, no problem. Then let us do the calculation. 2 into 4 minus 6 divided by 2, that is 2 into 4 minus 1 into 6 divided by 2. The answer of this one is 2 into 4 is 8, 8 minus 2 is 2, 2 divided by 2 is 1. Then second term calculation is 2 into 8, 2 into 8 minus 1 into 0 is 0 divided by 2. This 2 get cancelled. Answer is 8. Okay. For fourth row calculation, let us begin with first 1 into 6. 1 into 6. Next one is 2 into 8. 2 into 8 divided by 1. 1 into 6 is 6. 2 into 8 is 16. 16 minus 6 is 10. So here you can say that this is minus 10. Then 1 into 0, 2 into 0, its answer is definitely 0. Then minus into, for last row calculation, minus 10 into 8, this is minus 10 into 8, minus 1 into 0 is 0 divided by minus 10. This minus 10 get cancelled. The answer is 8. In this problem, you can see that in the first column having a negative sign. So that means the given system is unstable. You have to remember always, if negative sign appear in the first column, then system is unstable. Here we can see that there are 2 times sign is changed, that is from the order of s square to s raised to 1. First time sign has been changed. Again from s raised to 1 to s raised to 0, again sign is changed, that is plus to minus. First Again minus 2 plus second, there are 2 times sign changed. As a summary, there is a negative sign in the first column, hence system is stable. And the second one is here 2 times sign is changed in first column. It means that 2 poles in RHS side of the S-plane.